So it means that the upper class boundary is given as upper class interval plus 0.5. And the lower class boundary, it is what is given as the lower class interval minus 0.5. So for example, that we say that the example, the class boundary of what? Of class interval from 18 to 20 is what? Is 18 minus 0.5 to what? To 20 plus 0.5. So this makes what? So the class boundary, the lower class boundary will be 18.5 to what? To 20.5. That is simple. So that's all about the class, the concepts of the 6 terminology, which means the class boundary or the class limit. Fantastic. So we have the 7th terminology, which I've already mentioned, but we didn't discuss. And this terminology we call frequency. Say frequency. This is very important terminology in science, in engineering, in telecommunication engineering, in mechanical engineering, in acoustic engineering, means that sound engineering. These terms also we find in many cases in electrical engineering. For example, the domestic electricity is frequencies range from 50, for example, yes, 50 Hz to what, or 50, yeah, 50 complete cycle, 50 Hz to 60 Hz. You see, so that they're all about frequencies. So it's very important in computer. For example, the speed of the computer, we measure the speeds, or we used to measure the speed by using that. Just it means that what are the number of executions can be performed in a second. So this one in statistics we use a small letter f. So so the word frequency is used. So but we have to understand when we mention about frequency in statistics what we mean. For example, in this example, we have used that the frequency and then we count that f is equal to that and that and that. So the fundamental question is, what is frequency? Right? You have been solving statistical question, but possibly didn't ask yourself, what is frequency? What is frequency in statistics? So you can say that what is frequency in statistics? Right? Because you can have frequency in mechanics, but frequency is the number of complete cycles per second. Right? So in circular motions we have frequency. We also, whenever we learn about gravitations, gravitations is kind of, yes, we have frequency in gravitations, but it's slightly. But in case of rotational dynamics, also we have the terms frequency. So even in case of wave, in vibrations and waves, we have the term frequency. So we define in the number of completed cycles per second. But how do you define the term frequency in statistics? So this is the one of the definitions. So we say that in statistics, we specify. That's why we say in statistics we want to narrow. Okay, the concept. We say the frequency of an event. The frequency of an event. Right, of an event is the number of times. So still have slightly similar meaning. Number 40, number of times. So in the number of times, the observation occurred. Observation occurred or recorded. Whether observation occurred or recorded in an experiment. In an experiment. In an experiment or study. So I say frequency in statistics is the frequency of an event. is the number of times. How many times does the event? So the number of times the observation occurred or recorded in an experiment or what was done. So, example frequencies I've already given you in group data. We see these technologies mostly in group data. So, so for example, that we say that example frequency, let's just insist, we say that we have age of students, of ordinary diploma students, range from 18 to 20, then 21 to 23, then 24 to 26. And then say frequency, we had 60 students, so the range, so this is the way that, so how many times, so what the meanings. So within the range from 18 to 20, how many observations have been recorded? 2. So that's why we say that the frequency of the class interval from 18 to 20 is 2. Then between 21 and 23, how many events or observations have been recorded? 2. So between 24 and 26, how many events have been recorded? 2. So that's why the frequency is 2. It doesn't mean that it's common in most cases of statistics to have the same frequency for all the class intervals, but according to the example that I've been using to teach you. So that's all about what frequency. We'll be dealing with it in different cases. We have different ways of defining, but it's enough. So the seventh terminology of statistics, the seventh terminology of statistics, not the eighth terminology. The eighth terminology of statistics, we call it the frequency distribution table. Before I teach you about cumulative frequency distribution table. Frequency distribution table. Frequency distribution table. Say frequency distribution table. So the fundamental question is, what is frequency? So what is frequency distribution table? So what is frequency distribution table? That's the question that we have on the spot. Simply say that frequency distribution table, we say the method of organizing, is the method of organizing raw data in a compactive form. In a compactive form by displaying a series of scores in ascending or descending order. So simply say that cumulative distribution table, frequency distribution table, excuse me, I'm one step ahead of you. Frequency distribution table is the method. So this is the method. It's a method of organizing raw data. So we organize raw data, in a compactive form by displaying a series of scores in ascending or descending order. So for instance, this is ascending order. So you find the lower class interval is at the top, while the higher class interval is at the bottom. So this is the example of frequency distribution table. So it's a method of organizing data. So you organize the raw data instant and group data in a compactive form. So this is a compactive form by displaying a series of scores or series of observations recorded in ascending or descending order. So we'll be forming many frequency distribution, or we'll be given many frequency distributions in this module, and we have to answer the questions by using these concepts of frequency distribution table. Very important terminology. So for example, so we say that example, refer table, let's say 1 or table 2.1 above. So this is table 2.1. So this we call it frequency distribution table. Okay, frequency distribution table. So like this one. Even the previous tables are also, we call them frequency distribution table. It might have a column it must have the columns of the class interval or the class mark, and also it must have the column for the frequency and the columns for the class mark in case of group D, the class size, the columns for the deviation sometimes. You might have the columns of cumulative frequency. You might have the columns of maybe deviation, square of the deviations. You might have the columns of the products between the frequency and deviation. So it might have many columns and many rows according to the size of the raw data. So that's all about frequency distribution table. So the ninth terminology, we call it cumulative frequency. So say it cumulative. Will you call your first one cumulative because of your love in mathematics? So cumulative frequency. Say cumulative frequency. So the terminology is called the cumulative frequency. In short, we can call it CF, means that cumulative frequency. And the fundamental question that I was asking myself also as an engineering student, what is cumulative frequency? I know how to find the cumulative frequency of the particular problem. But what is it, cumulative frequency? In statistics, okay? What is it? So I found several definitions, but this is one of them. So I say cumulative frequency is the value used to determine. So we say that this is the value. So this is the question mark is a value. Is a value. Is a value that is used So this is the value that is used to determine what? Determine the number of observations. The number of observations that lies above or below below a particular value, in a set of data, in data set, or in a set of data. So that's the means of cumulative frequency. We say the value that is used to determine, so this is the value that is used to determine the number of observations that lies above or below what? A particular value in what? In set of 40 of data. So that's the meaning. So it's the value that is used to determine the number of observations that lies above or below a particular value in set of 40 of data. That's the meaning of 40 cumulative frequency. So how do we find cumulative frequency? How do we compute? So the question is, how do we compute? How do we compute cumulative frequency? Right? Suppose that we have a frequency distribution table that maybe we have class interval, right? So this is class interval 1, so you have, let's say, class interval 1, let's say class interval 1, so we say that maybe class interval 1, class interval 2, class interval 3. And then they have also frequency, so you have frequency 1, we have frequency 2, we have frequency 3. It's another column. So then we want to compute the cumulative frequency. So the cumulative frequency for this case, the first cumulative frequency will be the frequency 1 plus 0. The second cumulative frequency will be the first cumulative frequency plus second cumulative frequency. The third cumulative frequency will be the first cumulative frequency plus the second cumulative frequency plus the third cumulative frequency, etc., etc., etc. So this is the way that we can compute the cumulative frequency, and we'll be taking example step to step like this. Right, so this is rows, the first row, this is the second row, this is the second row, the third row, and this is the first row. So that's how we can compute. So you can take an example of cumulative, means that how we can compute the cumulative frequency. So for instance, you want to add, okay, so let us use this simple example. Then we'll go to the example and then say, I'll give the homework for you. So, example of cumulative frequency, we say that, so consider that you have the H in years, and then you have the, maybe the frequency, then you have the cumulative frequency. Possibly you can have even the class mark, the class size, so all those data are relevant. So the frequency, it is 2, the cumulative frequency will be 2 plus 0, it is 2, the class mark we found is 19, the class size is 3, right? Then you have the next class interval, which is 21 to 20. So the frequency is 2, the cumulative frequency will be 2 plus 2, which will be 4, and then the class mark is 23, and the class size is 3. So the next it is 24 to 26, that's the next class interval, and the frequency is 2. Then the cumulative frequency will be 4 plus 2, or will be 2 plus 2 plus 2, which is equal to 6, and the class mark is 25, the class size is 3. So this is the case. So this is our statistical data, like this. Then you have the next statistical data, you have the next statistical data, then this is the case, and this is the case, and this is the case. Right? So you see the cumulative frequency. So again, you can go the further step, and we may say that we can have also something called the summation of the frequency. For this case, you sum 2 plus 2 plus 2 is equal to 6. So always the sum of the frequency will be equal to the last cumulative frequency if the data have been arranged in ascending order. So that's those are all, or some of the fundamental terminologies used in statistics. So now I would like just to give you an example relating to this concept. We had the first example was the homework 2, homework 1. After this example, I'll leave the homework for you so you can solve it. So this is example 2, because example 1 was the homework that I left to you in lecture 1. So this is the example 2. So in example 2, the question states that given 72, this is raw data, we call it in statistics raw data, 62, 60. If you are joining me right now, you're warmly welcome. My name is Olenjolai from the United Republic of Tanzania. Welcome to learn statistics for basic engineering mathematics and basic scientific mathematics 65. Then you have 64. Then you have 67. Then you have 66. Then you have 62. Then you have 63. Then you have 61. Then you have 77. Then you have 74. Then you have 72. Then you have 73. Then you have 70. Then you have 64. Then you have 68. Then you have 69. Then you have 63. Then you have 74. Then you have 64, 70, 64, 68, 69, 63, 63, then I jump to 74, 66, then you have 65, then you have 68, then you have 73, then you have 71, then you have 73. Okay? Construct a frequency distribution table. Construct a frequency distribution table. Construct the frequency distribution table for 6 class interval. For 6 class interval. So how many data do we have there? Several data. Questions say that if we given raw data 72, 62, 60, 70, 75, 65, 64, 67, 66, 62, 63, 61, 71, 77, excuse me, this is 77, 74, 72, 73, 70, 64, 68, 69, 63, 74, 66, 65, 68, 73, 71, 73. Construct a frequency distribution table for 6 class intervals. So here we have a plural for 6 class intervals. Solution. So I will solve this problem, but I will give you the homework. After solving these problems, I'll give you the homework. Then will be the end of lecture 2. So you have to join me in lecture 3 of statistics. Beautiful subject of engineering mathematics. So we given that. So we have to find or to construct a frequency distribution table for 6 class interval. So remember the formula that I taught you of how to determine the class size. Because whenever you want to construct this frequency distribution table, we should also know the class size of that class interval. Because we'll be given different raw data. So I will teach you how to solve these problems by following number of steps. So the first step, we say that identify the maximum or find the range of the given data. Find the range, according to the formula, range of 40 of the given data. So the range of the given data, given raw data, right? So the range, I told you that you can determine the range by taking the maximum data, the maximum value, minus the minimum value. So the range for, because we'll be given ungrouped data, from group data, what the maximum value there? So the maximum value is 77. If you examine the maximum value here, it is 77. So where is 77? So this one. Then what the minimum value? So the minimum value is 60. So where is 60? So this is 60. So it means that the range for this group data is 77 minus 60. The answer, the range is equal to 17. Right? It's equal to 17. Great. So it's at the range. And then we say that the next step, we have now to compute the class size by using the range of ungrouped data and what? Range of ungrouped data and the number of classes. So the second step, we say that let us compute it. Let us compute the class size of the statistical data. So the class size, so we say from this formula, the class size is equal to range of ungrouped data of what? Number of classes. So the range for ungrouped data for this case is 17. The number of classes is 6. We have to construct a frequency distribution table of 40 of 6 class intervals. So the number of class intervals, or the number of class, yes, the number of class intervals that require to be formulated. If we form five class intervals, then the class size will change, interval. Okay? So you can use your calculator. If you divide 17 over 60, it is 220. Answer is 220. Using your scientific calculator, 2.8333, so it's a recurring decimal. 8333. And this one, because the class size always is a whole number, so we have to estimate 2.833, and this will make 3. So the class size, C, or we call it I in some of the books, is equal to 3. So we know now the class size. And then we have to go to the third step. After knowing the class size, that's not enough, but it's one stage ahead to the solution. So then the third step, we say that, okay, fine. So the next step now, we know the class size, then we have to know we have to identify what? We have to identify the class, because we have to identify the class, the range of the class interval. So use the class size. The number of classes is 6. That's required. Then use the class size to find the difference between the lower and upper class interval. So we say that use what? Use the class size to find or determine the range. Or determine means that, yes, the range between what? Between the lower class boundary, lower class interval, and what? And upper class interval. So upper class interval. So how do you use the class size? Remember that from the formula that I told you. The class size is equal to what? Is equal to upper class interval minus what? The lower class interval plus 1. Right? So remember that the upper class interval is not equal to the upper class boundary or upper class limit. And the lower class interval is not equal to lower class boundary or lower class limit. So if it's the case, we can make this range the subject. So class size minus 1 is equal to upper class interval to lower class interval. So 1 determine the range. So what the class size? Class size is 3 minus 1. So this will be upper class interval minus the lower class interval. So 3 minus 2 minus 1 is 2. So this is upper class interval minus lower class interval. So the range of the class interval is 2. So now we can start formulating our frequency distribution table, because we know now, so we can construct our frequency distribution table of the 6 class intervals. So that will be the first step. We can construct it now. And constructing the frequency distribution table, right? The frequency distribution table. So you have class interval, and then here we have frequency. So we have to formulate 6 classes or 6 class intervals. So the first class interval is from 60, and then so you add 2. So you count how many numbers exist within this range, 63 to 65, and then so you have 66 to 67 or to 68. And then so you have what, 69 to 71. Then you have 72 to 74. Then you have 75 to 77. So you have to count how many numbers range from 60 to 62. So 1, 2, and then 3, 4, 4, 4, 4, 4, 4. So you have 4 numbers, so the frequency is equal to 4. So you do the similar step, so you count 4. So again, you can count the numbers range between 63 to 65. If you do your counting well, you get 6. And then so you do the counting for numbers range from 66 to 68. When you do your counting, will be 5. Then you count number from 69 to 71. The counting number is 4. And then the frequency is 472. They count the numbers between 72 and 74. Then you find that the frequency is 7, and find the numbers range, count the numbers range between 75 to 77, and the number is what? Is 2. You can also find the sum of what? Of the frequency. So, the homework now. That should be the example 3. This is homework 2. So given all of those information, but now constructed a frequency distribution table of what? Frequency distribution table for these cases. Normally R for 4 class interval. 4 class intervals. Make sure that you do this homework before you take or before you learn the contents of lecture 3. B, you have to also to consider the frequency distribution table for 8 class interval. So we'll be given the same data, but now the class interval has been from an A has been reduced from 60 to 4 class intervals, and from an B we have added 2 class intervals from 60 to 8 class intervals. So I believe that if you've understood the contents that I've been teaching, that questions will be very simple, and I believe that you will solve it before you join me in lecture 3. So that's the end of lecture 2 of statistics in the modules of probability and statistics for diploma engineering and scientific students who are taking engineering courses and science courses. So I thank God who have prepared me and gave me this chance and give me this idea and give me this opportunity to solve the problem. Doesn't mean that I know everything concerning probability and statistics, but I know just a small portions of it, but I'm ready to teach millions of the students about what I know concerning about probability and the statistics. Maybe the world great for you, but to me just a small portion, because I'm always learning different concepts of probability and statistics. However that you have graduated, maybe the lessons that I'm teaching you are in undergraduate level, so it's still it's a subject that I need to apply in my engineering careers. So please make sure that you do some few issues that, or some few issues that I have shared to you at the beginning of this lecture. I thank God also have given us the opportunity to join me in this fantastic lecture. In case you have any questions or you have questions concerning about what I have told you in statistics, probability and statistics, make sure that you ask in the comment sections, and also you visit the comment sections to check and to learn and just to learn through questions that have been asked by other students in the world. So please also tell us in the comment sections you are enjoying this material from which continent, from Africa, from Asia, from America, North America or South America, from Australia, or from Europe, possibly. And also in which country, after you mention the continents, in which country, and then in which city of the country, or in which institutions, in which college, in which university. We are very happy to hear about that, so we can know the widths or the expansions of this idea to millions of the students who are pursuing different courses in engineering and different courses in science and at the ordinary diploma level. Enjoy mathematics more than I do, and make sure that I will be encouraging I'll be encouraging you in many cases, especially that to like the engineering mathematics and think how you can apply for your daily life or to solve the real world problems existing in your nations or in your city or in your village or in your local street, and even just in your family, because you can use them to solve problems in your family. So thank you very much. This is Olenjolai from United Republic of Tanzania. I'm happy to be with you, or I'm happy to be a part of your academics. Still enjoying the engineering mathematics. Join me in lecture 3 of statistics. May God bless you.